There are a number of ways to count atoms. One of the simplest was devised by the famous Kiwi physicist Sir Ernest Rutherford. Rutherford was investigating radioactivity. One kind of radioactivity produces alpha particles. An alpha particle is a helium nucleus, 2 protons and 2 neutrons. Now, Rutherford didn't know that, but he did know that alpha particles turn into helium atoms, 1 helium atom per alpha particle. Alpha particles produced by a radioactive element such as radium can be counted by counting the flashes of light produced when the alpha particles hit a screen of zinc sulfide. In 1903, Rutherford arranged for the alpha particles produced by a sample of radium to be counted and trapped. In 1 year, the radium had emitted 1.16 by 10 to the 18 alpha particles, which had then formed 7.7 by 10 to the minus 6 grams of helium. If 7.7 by 10 to the minus 6 grams of helium contains 1.16 by 10 to the 18 atoms, how many atoms are contained in 4 grams of helium? Well, when you do the maths, it works out at 6.02 by 10 to the 23 atoms. This number is called Avogadro's number, in recognition of the work done by the Italian scientist Amedeo Avogadro. It was previously defined as the number of atoms in exactly 12 grams of the carbon-12 isotope in its rest energy electronic state. However, in 2019, the kilogram was redefined so that it was no longer based on the mass of a physical object, a platinum iridium cylinder in France. It's now tied to the smallest action that can be made by a photon, which is essentially the smallest possible physical action there is, called Planck's constant. Anyway, when the kilogram was redefined, this meant that Avogadro's number also had to be redefined, as it was previously based on the kilogram. Since March 2019, Avogadro's number has had the exact SI definition of 6.022140076 by 10 to the 23. The figure is generally accepted as 6.022 by 10 to the 23. Since the redefinition of SI base units, the number is fixed, and the mole is defined based on this constant. The number is significant in that it serves as a bridge between the microscopic world of atoms and the macroscopic, measurable world of grams, allowing chemists to count particles by weighing them. Avogadro's number is a dimensionless number, having no units. However, since it gives the number of entities per mole, the System International de Unité additionally defines Avogadro's constant as having the unit reciprocal mole, or per mole. The equation is Avogadro's number is equal to the number of entities present divided by n moles of a substance. This can be rearranged to give the number of moles, number of entities divided by Avogadro's number. Well, that's the video done. If you liked it, brilliant. Hit the like button and leave me a comment too. Now you know what to do. Go hit that subscribe button. We'll see you next time.